In this video, we're going to add a size method to our public class IntTree. So what we want to look at when we're looking at the size of a binary tree is we want to return the total number of nodes. And in general, when we have a public method, we're always going to have a corresponding private method. You can imagine it as kind of the public to be the exterior, what people can see, and the private to be kind of the interior. An easy example would be a radio. The outside of the radio is public to people, and the private wires are kind of not available for everyone to see. If we didn't have a private method, then our radio would just kind of have its wires all dangling out, and it would look very unappealing, and nobody would personally buy our radio unless they're kind of into that kind of stuff. So anyhow, let's get started here. So our size method is going to be of the type integer, and we're actually not going to take any parameters because we don't want our size method to do any work. We want it to all rely on the private method so that everything looks nice and pretty in the end. So what we're going to do is we're going to call upon another method, our private method, and let's not be creative and let's call it size. And it's going to take a parameter which we can actually call anything, but most people tend to call it something along the lines of overall root. Why? Because that's going to be the current root that we're looking at in terms of where we're at in the tree. So once again, we need a private helper method, and we declared it to be size, and it's going to return the type of an integer. And because we said that it's going to take an overall root, which is going to be the nodes that we're looking at in the tree, we're going to take in an IntTree node, and we're just going to call it root. So we have what's our base case here? Well, what happens when our root is null? Well, it means that we have nothing to look at. So we're gonna make the case here. So if the root is equivalent to null, we just want to return nothing. So we'll return 0. Do we have anything else that we care about? I'd say no, because otherwise we know that we're gonna look at another kind of node here. So we need to recursively backtrack. So we see that we know at this point at least one root. So we're going to return 1 plus the size, and we're going to check to see if we have a left side of the root, and we're going to check to see if we have a right side to the root. And this should actually do the trick here. Thank you guys for watching. See you in the next video.